There's a cow pooping in the background. Oh, gee willikers. I'm not wearing a hat. My hair's a hot mess. In my last video, I talked about the acronym PAAST to describe how we're going to do nodal analysis in AC, where the steps are phasor transform, assign, apply, solve, time transform. And we're going to use the acronym PAAST to talk about how we're going to handle stuff for mesh analysis. And instead of using something else, today I'm going to talk about my past and show you around my hometown in Ohio. I don't have any good pop culture references for today. All I can do is tell you that my hometown is home to the first Congressional Medal of Honor winner, and it's where they made the cap gun for Gene Autry, the singing cowboy. There's not a whole lot else to say about this. That's the courthouse right behind me. In winter, they light it up with lights that hang down from the ends. It's pretty neat. And I'm going to walk around here until my wife picks me up. Okay, so understanding the acronym PAAST, let's do an example. In this example, what I have is an AC circuit and I would like to find the loop currents. Let's start with step 1, which is to take the phasor transform. I notice that the voltage source is 10 cosine 10t, so omega will be 10 and the phasor transform is 10 angle 0 degrees. Similarly for the current source, the phasor transform is 3 angle 30 degrees. Looking at the inductor, j omega L is j times 10 times 0.1, which is equal to j1. For the capacitor, 1 over j omega c is negative j over 10 times 0.1, or negative j1. The resistor remains the same. Let's redraw the circuit with the phasor transform values. Step 2 is to assign the loop currents. Step 3 is to apply KVL, but what I notice is that there is a super loop, so I say, stop! It's super loop time. I start by writing the constraint equation, which is I1 minus I2 is equal to the current source between, which is 3 angle 30 degrees. Then I write KVL around the big loop. Starting at the lower left hand corner, I get negative 10. Going to the resistor, I get 1 I1 as the voltage across it. At the capacitor, I get negative J1 I2. And at the inductor, I get J1 I2. That completes going around this loop, and so all of these voltages are equal to 0. What I should notice is that negative J1 I2 and plus J1 I2 cancel out, and so I'm left with the equation I1 is equal to 10 angle 0 degrees. Step 4 is to solve. I know immediately from equation 2 that I1 is equal to 10 angle 0 degrees amps. Plugging this value into equation 1, I get 10 minus I2 is equal to 3 angle 30 degrees. Converting 3 angle 30 degrees to rectangular form, I get 2.6 plus J1.5. That makes this expression 10 minus I2 is equal to 2.6 plus J1.5. Solving this in rectangular form, I get 7.4 minus J1.5, or in polar form, I get 7.55 angle negative 11.46 degrees amps. Finally, we come to step 5, which is the time transform. Here we have I1 equals 10 cosine of 10t amps, and I2 equals to 7.55 cosine of 10t minus 11.46 degrees amps. And that completes the example. Well, I hope that you enjoyed a little trip through my past as we talk about the key acronym PAAST, which we use for mesh analysis. Remember, the steps are phasor transform, assign, apply, solve, time transform. Thanks for watching. If you enjoyed this video, I would greatly appreciate it if you would subscribe. You can connect with me on Twitter or Instagram at BD McPheron. That's all for now. See you soon then.